Question 5 on the Edx M2 Jun 2010 paper was on impulse and momentum. And just take a moment to read the question carefully and then continue playing the video. Here's the first part of the question then. So this question needs you to use what you know about impulse and momentum. They mention the word impulse down here. That's the key. So the equation that you're going to quote, let's use a sensible colour, not red, is impulse equals change in momentum, mv minus mu. Now this question is phrased in vector terms, so we want to, it's not motion along a straight line, we need to use this equation in vector form. And we have to find the impulse, okay? So we're given that u, the initial velocity, is 1024, and v, the velocity after impact, after the impulse, is 20, 0. Yep. So plugging that in then, I equals 0.5 m into v minus u, 20, 0 minus 1024. Let's use some room on the left hand side here then. So I works out to be, the impulse is 0.5 times 10 minus 24, which comes to an impulse in vector form of 5 minus 12. And we're nearly there, we've nearly got the 4 marks, but read it carefully. The question asks for the magnitude of the impulse on the ball. So the magnitude of impulse squared, the usual method for finding the magnitude of a vector in 2 dimensions, is 5 squared plus minus 12 squared, which comes to 169. So the magnitude of impulse is 13 Newton seconds. That's this part of the question done. On to the second part. And the second part, quite a very commonly asked question. They want to find the angle between the vector I, the x direction then, and the impulse. So from the previous part of the question, the impulse was 5 minus 12. So I'll just draw a little vector triangle for that. 5 that way and 12 down, and that's the impulse there. Let's call this angle theta. And we've got tan theta, opposite of adjacent. So tan theta is 12 over 5, and theta is 67.4 degrees. Okay, that's part B done. Last part, kinetic energy lost. So, kinetic energy is a half mv squared. So if you've got the velocities in vector form, you've got to work out v squared, which means the magnitude of the velocity squared. So the ke after was a half times 0.5, the mass is 0.5, times 400, and the k before was a half times 0.5. It'll be 10 squared plus 24 squared will be the magnitude of the initial velocity, because it was 10I plus 24J. So the k after, k before, we've got to take the difference. They tell us there's a loss, so we do k before minus k after. If you evaluate those two kinetic energies and subtract them, two minus 1 gives the loss, which comes to just 69 joules of energy. Right. So that question was worth, let's go back to the first part. The question was worth a total of 9 marks, 4 marks for the first part of the question. And those 4 marks consisted of basically 2 method and 2 accuracy marks. There was a method mark for the impulse momentum equation and an accuracy mark for creating that equation properly, putting the right vectors in. It was 4 marks for this question, wasn't there, for this part? Yeah. And then there was a method and accuracy mark for finding the impulse as a vector and then finding the magnitude of it. So here, an M1 and an A1. There's 4 marks for that part. The second part of the question, the middle bit, 2 marks and then 3 marks. So for finding the angle, there was a simple M1, A1 for creating the triangle and finding tan theta and finding theta. And for the last, kinetic energy lost, again there was 1 method mark and 2 accuracy marks for quoting a half mv squared and then evaluating the kinetic energies and the loss. And that was your 9 marks. Okay, thank you for listening.